Hi Math 2 students, and welcome to your 3.5 Ed Puzzle. So 3.5 is called Solving Quadratics Using the Quadratic Formula. The x-intercepts of the graph of a function are the solutions to the equation. So we talked about this before, right, that this isn't a good highlighter, that the x-intercepts are also called the solution, okay? So to reiterate what the x-intercepts are, that would be where the function hits the x-axis. In Module 2, we learned how to find the x-intercepts of the function by factoring, which works for some functions but not others. In this section, we are going to work on how to find the x-intercepts of any quadratic function that has them. Let's start by thinking about what we already know. What can you say about the graph of the function x squared minus 2x minus 3? Graph the function by putting it in vertex form. All right, so to get this guy into vertex form, let's remember this is in standard, right? And we're trying to get to vertex. So we need to complete the square. So we're going to do x squared minus 2x and then put our minus 3 on the outside. We're going to do negative 2 divided by 2 squared, which is going to give us a 1. And then we're going to go ahead and subtract that 1 on the outside. So then we're going to do y equals, or I guess this was f of x. We could do that. F of x equals, we're going to do x, and then remember, this number here is always this guy divided by 2. So we would do negative 2 divided by 2, which is going to give us a negative 1 squared. And then minus 3 minus 1 is going to give us a negative 4. So we've got the vertex form of the function. We know that our vertex is going to be 1 comma negative 4. So we can go ahead and put that in there. 1, negative 4. All right, so the vertex, 1, negative 4. Then they ask for the x-intercepts. Now, how do we get the x-intercepts? Remember, we factor and set the factors equal to 0. Now, keep in mind, like they said, this is one way to do it. We're going to learn a different method because sometimes this way does not work. All right, so remember we have to figure out what multiplies to give us a negative 3 and adds to give us a negative 2. So that's going to be x minus 3 and x plus 1. So then you set the factors equal to 0. So we get x equals 3. And we've got our x plus 1 equals 0. We get x equals negative 1. So our two x-intercepts are going to be 3, 0 and negative 1, 0. So we can go plot those. And then we've got our parabola here. All right, so this is all stuff that we've already learned how to do. So now we're going to go ahead and look at the function x squared minus 6x plus 4. So it says graph the function by putting it into vertex form. So let's get this guy in vertex form. Again, how do we go from standard to vertex? We complete the square. So we're going to do x squared minus 6x plus 4. We're going to take our middle term, divide it by 2, and square it, which is going to give us a 9. So we're going to add in 9 and subtract out 9. Keep in mind that none of these guys had a leading coefficient, so we didn't have to do any of that multiplying and factoring. Now I'm going to rewrite this guy as a perfect square. So I'm going to do x, take my middle term, divide it by 2, which gives me a minus 3, square it, and then 4 minus 9 is going to give me a negative 5. And then we'll put in our f of x. So the vertex of this function is 3, negative 5. So I'm put in my axes here. To kind of leave it up to you to put in the axes. So we're going to go 1, 2, 3, 1, 2, 3, 4, 5. All right. So now it says, what do you notice about the x-intercepts? So here's what we're going to do. I actually graphed this on Desmos because what I want you to do is let's see if we can factor this. We've got x squared minus 6x plus 4. Okay? So we have to, of course, figure out what multiplies to give us that and adds to give us that. So if we do that, right, the factors are 4 are 1 and 4. And then we could also do -1 and -4. And then 2 and 2, and -2 and -2. Those are our only options. Now when you add all these up, right, we get 5 for this guy, -5 for that guy, 4 for that guy, and -4 for that guy. Notice how we needed a -6, and none of these factors gave us a -6. So we can't factor this quadratic. This is not factorable. Let's go ahead and see what happens when something's not factorable. What do the zeros look like? So I have this function graphed here, and let's take a look at the zeros. So we've got 0.764 and 5.236. So those are our zeros here. Those are our solutions. Now notice these are very gross numbers. So when something is prime and you can't factor it, you're going to end up with some kind of crazy looking zeros here, solutions. So we've got 0.76 and 5.2. Whoops. So we got that guy, and then 1, 2, 3, 4, 5, and we went there. All right. So what do you notice about the x-intercepts? Essentially, you could just say that they are some kind of, we'll even just say they're ugly decimals, right? And that's not something we could have gotten by factoring. So it says, when we cannot factor a quadratic, we can use the quadratic formula to find the solutions. Standard form of a quadratic. So what is the standard form of a quadratic? Hopefully by now you guys know that. And that is when you have the function is equal to ax squared plus bx plus c. And then this is I know this looks really scary. This is the quadratic formula here. So in order to use this formula, we need to have our function in standard form. And then we figure out what these coefficients are equal to, and we plug them in. So we figure out what a is, we plug a in there and there. We figure out what b is, we plug b in there and there. We figure out what, we already did red. We figure out what c is, we plug c in there. Okay? So it says, now let's find the solutions using the quadratic formula. So in order to do this, let's go ahead. We're going to figure out what a, b, and c are equal to. So if we're looking here, notice how there's nothing in front of this x squared. When there's nothing in front of the variable, that's an implied 1, right? This is like 1x squared. So we could say a equals 1. This is our b. Now make sure you don't lose the signs that are in front of them. Since this is a -6 in front of the x, we're going to use b is equal to -6. And then, of course, we've got our c, which is 4. So now we're going to go ahead and plug into this formula here. So the first thing we need to plug in is -b. So we've got that b is equal to -6. So we're going to say -6. So how did I get that? We had to do -b. So I did a negative sign and then my b value, which was a -6. Then I'm going to go ahead and do plus minus. And then we get the square root. And then we have to do b squared. So we're going to do -6 squared. Then we do minus 4. Then we're going to multiply it times our a value, which is 1. And then we're going to multiply it by our c value, which is 4. And then we're going to put that all over 2 times a. So 2 times our a value, which is 1. So I know this looks super duper scary. It's like, oh my gosh. But we can do it, guys. So now let's try and simplify this a little bit. Minus -6 is going to be equal to +6. So we're going to say 6 plus or minus And then we end up with negative 6 squared. Now, please, 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 always remember that when you square a negative, it becomes positive. Don't just plug in negative 6. Actually, let's talk about that. When you plug in a number into your calculator, you're going to plug it in like this. You do parentheses, negative 6, parentheses, negative 6, and then you square it, okay? If you do this without parentheses, you're going to get the wrong answer. You're going to get negative 36. So make sure that you put that into parentheses. Ooh, we don't want that. So then we get positive 36 minus, and then 4 times 1 times 4 is 16. So we're going to do minus 16 all over, and then that's 2 times 1, which is 2. So we're getting there, guys. Now let's go ahead and continue to simplify. We've got 6 plus or minus the square root, and now let's do 36 minus 6. That is going to give us 20. All right. I'm sorry, 36 minus 16. I apologize. That's going to give us 20. And then we have that all over 2. All right. So now we're going to go ahead and simplify this radical here. You always look to see if you can simplify the radical. So we've got 20. We can break that down into 4 and 5, right? So if we've got square root of 4 times 5, that's going to become 2 root 5. Do you see here why I was saying it's so important to make sure you know how to break down these radicals? So now this is equivalent to 6 plus or minus 2 root 5 all over 2. So we're getting there now. But now we have to simplify it. So pay close attention to what I do here. It's quite tricky. We have this 2 on the bottom, and we're going to try and see if we can simplify. Now, you cannot do this. A lot of people want to go, oh, I can just cancel those out, and it becomes 3 plus or minus 2 root 5, right? You cannot do that because you have a plus and minus sign there. So what you need to do is you need to see if there's anything you can factor out of this top portion. You can take a 2 out of 6 and 2. So we're going to take a 2 out, and we get plus minus. Oh, sorry. We get 3, right? Because 6 divided by 2 is 3. Plus minus, and then when you do 2 root 5 divided by 2, you just get root 5. That was all over 2. So your final answer here would be 3 plus minus root 5. So really we've got 2 solutions here, right? So we've got x is equal to 3 plus root 5, and x is equal to 3 minus root 5. Now this is how I want you to give me your answers, right? You should leave them in this radical form here. But let's just check to see if we're right? We went and we said, okay, well, this guy here is equal to 5.2. Let's see if we can get the 5.2. If we do 3 plus the square root of 5, we get that 5.23, that gross number, right? Then the other one was 3 minus root 5. And that gives us that 0.76 that we had. Remember? 0.76, 5.236. So that tells us we did it right. So those would be our 2 solutions. All right, so let's go ahead and try the next one. It says, find the following information for each quadratic function. So first off, it says, does this factor? So let's find out, does it factor? We need to figure out what multiplies to give us negative 20 and adds to give us a positive 8. So if we got negative 20, we could do negative 1 and 20. We could do positive 1 and negative 20. Those would add to give us 19 and negative 19. So those aren't going to work because we're looking for an 8. We could do negative 2 and negative 2 and 10. And we could do positive 2 and negative 10. Look in here, these guys are going to add to give me my 8, right? So you could say, yes, this does factor. So we would get x minus 2 and x plus 10. So then we should know how to find the x-intercepts, right? We set these equal to 0. So we get x equals 2. We get x equals negative 10. So our x-intercepts here would be 0, comma 2. Or I'm sorry, no. It'd be 2, comma 0 and negative 10, comma 0. And then, of course, the x-intercepts are the same as the solutions, right? So we do 2, 0, negative 10, 0. Those mean the same thing. Now, let's go ahead. They want us to use the quadratic formula here. So let's see, using the quadratic formula, do we get 2 and 10? Well, let's find out. So if we're looking here, we've got an a of 1 again, a b of 8, and a c of negative 20. So let's give it a shot. We've got a equals 1, b equals 8, and c equals negative 20. So now let's go ahead and plug these in. Again, I'm going to write the quadratic formula here. We've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we're going to do negative 8, which is our b, plus or minus the square root of b squared, which would be 8 squared, minus 4 times a, which is 1, and c, which is 20. And that's going to be all over 2a. So that's going to be 2 times 1. So now let's go ahead and work to simplify this. We would get negative 8 plus or minus, and we get 64, minus, and then 4 times 1 times 20. It's going to give us, oh, I messed up. This was supposed to be a negative 20, right? There we go. So 4 times 1 times 20 is going to give us a negative 80. I was like, something's not right there. And that is all over 2. And then we could do 64 minus negative 80, which is going to give us 144 all over 2 still. And then we know how to simplify this radical here, right? What is the square root of 144? That's 12. Excuse me. So we're going to do negative 8 plus or minus 12 all over 2. So now let's go ahead. Let's break this apart into the two parts, right? We'd have negative 8 plus 12 over 2 and negative 8 minus 12 over 2. That's where that plus minus comes in. And we would get 4 over 2 and negative 20 over 2, which is going to give us 2 and negative 10. Which notice how that matched up perfectly with our solutions and intercepts.